Hello, Ron Shook here, and my students, you already know your roles and have opened a spreadsheet because you've already looked at the daily agenda. Today, I'm going to show you protocols for how to do some simple chemical tests to help assess stream quality. So, you will obtain a sample in a beaker like this. Today, we will do fish tank and we will do tap water. Most likely tomorrow, we will do Squaw Creek and something called a bioreactor. First thing you need to do is open up the kit that looks like this. It is your dissolved oxygen kit. And in there, you will find something that we will call the sample tube. Take the water you want to test and fill the sample tube up to the line that says 25 milliliters right here. We're going to begin today with a test of chloride. So this green colored item, you'll take out this Quantab. This fabric here will draw water up. When the water hits this orange area, that will turn black, which means the test has been developed and is complete. We'll get that started right away, just putting the tab right in there like that. It will take 5 to 10 minutes, so we'll set this aside for now. The next test that we'll do is pH. pH is a measure of the balance in water. It will be acidic with pH below 7, basic or alkaline with a pH above 7. So here's what that tube looks like. It will have a color scheme that will help you determine the pH based on an indicator change. I take out my tab. I can go back to my original sample in the beaker, dip, count to 15, or use a timer. We're going to get a look up here and look at these colors. We're at about that 15 point now. And I'm going to come right in. We're going to be fairly neutral here, so probably about a 7 on that one. You have a little garbage can near you. You may dispose of the tab into the garbage can. Similar type of test for nitrite, nitrate. Nitrates in streams can cause problems with algae blooms, overgrowth and shading out of biodiverse species of plants, algae death that can then be consumed by bacteria, using up oxygen in farm ponds and shallow ponds, causing fish kills, or those things can happen all the way down in the Gulf of Mexico, leading to a dead zone. Again, the strip is dipped for a second, 30 seconds, and the nitrite will be developed. 60 seconds and the nitrate will be developed. You can see here I have my thumb. Your thumb would be holding the strip, something like this. The bottom will show nitrite. The top will show nitrate. We're coming up on about 30 seconds, and on the bottom, the nitrite looks about 0. We'll wait a little longer for the nitrate. We're looking for shades of pink. So this sort of tannish background is a 0. till we start to see shades of pink. Anything above a 5 will be obviously pinkish to red, and that's just not happening with this particular sample. So this particular sample is also going to be 0 in nitrate. Coming back to our test for chloride, often going to be in streams as a result of road salts that have been spread in the winter. We do tend to get peaks at times of snow melt. The black tab is fully developed. And the fun thing down here is you now see this white area that comes to a point. And that is coming to a point at the 2.2 level. I can throw the tab in my little garbage can. What I now need to do is once again come back to the container that the quant tab was in, and we have some numbers here. I'm finding the 2.2 number. You will read over to the right, and the third column over will be parts per million, and 2.2 is converting to 53, and 53 is what will be recorded on the spreadsheet. Finally, what I think is a really fun one, you'll reach into your oxygen tester. You will take out, actually you can go back to the tube that you've already filled up, and you can reuse this water here. You're going to go to a box that looks like this and pull out something called an ampule. These are fun. They are vacuum packed. That means there are no molecules behind the liquid. What that means, when we snap this end off below water, the pressure of the water will push the water right into this tube. It'll fill up, it'll look cool, and it does a very pretty color change. To do the snapping, we place the ampule in here. I will be applying pressure at 90 degrees to the ampule, and it will snap this off right here. You will hear it snap, and this is now full. And you'll see a little bubble in there, and we will spin this, and that bubble will continue to mix the indicator with the water sample. The darker the blue, the more dissolved oxygen. This test takes 2 minutes to develop. Having someone in the group time, that would be a great thing for the assistant to be working on. Time it on the clock, time it on a cell phone timer, time it on an online timer with your computer, any of those. As we approach the 2-minute mark, I will bring our color comparator, again using an indicator that has different colorings with different amounts of dissolved oxygen. We are obviously above these low numbers of DO. We're going to come over this way, and now we're getting fairly warm. We are probably a little greater than 6. And I'm going to call it today right around 8. 8 parts per million dissolved oxygen. Fish need a minimum of 4. Higher is better. A lot of organisms will struggle anywhere down below 3, really. Invertebrates are going to be struggling, and it's going to be very difficult for ecosystems to be supported. At this point, we can take this and dispose of it in the garbage can, right, like that. You may pour the water off into a sink. There will be a little piece of glass at the bottom that can be tapped down again into the garbage can. Repeat with other samples. Thank you so much, and have some fun.